Hey folks, welcome to my channel number 10. So there we have the problem on our screen. Integrate the following with respect to x, and we've been given cos 2x minus cos 2 alpha divided by cos x minus cos alpha. So here x is the independent variable and alpha is a constant, right? So what we've been given is dy by dx, and we've been asked to find our y, right? And y is nothing but integral of the given expression, right? Let's write it down. So there we have the expression for y. I might have to do a little bit of simplification before I can reduce y to a much simpler expression whose antiderivative I can quickly find out using the integral formulas, right? So I know that my numerator has cos 2x minus cos 2 alpha and my denominator has cos x minus cos alpha. So I'm going to try and express my numerator in terms of x and alpha rather than keeping it as 2x and 2 alpha. So let's go to the next line. And I know that my cos 2x is nothing but a cos square x minus sine square x, right? And if you do not know this identity, please familiarize yourself with this because these trigonometric identities are going to be the backbone in integral calculus whenever it comes to solving trigonometric problems in integral calculus, right? So I know that my cos 2x is equal to cos square x minus sine square x, which means my cos 2 alpha also is cos square alpha minus sine square alpha. So I'm going to leave y as it is. I'm going to take out this particular expression and see what I can do before I get back to my y. So let me write down this particular expression cos 2x minus cos 2 alpha divided by cos x minus cos alpha. I know that my cos 2x equal to cos square x minus sine square x, right? And I also know that my sine square x plus cos square x equal to 1, right? Which means the same formula can be written as 2 cos square x minus 1. Are you folks with me? All I'm doing is rewrite sine square x as 1 minus cos square x, and then I add the cos square x with the existing cos square x. I get this particular identity here. So my cos 2x is 2 cos square x minus 1. And similarly, my cos 2 alpha will also be 2 cos square alpha minus 1. So now I'm going to rewrite this. So my cos 2x becomes 2 cos square x minus 1. Then I have a minus of cos 2 alpha, which is nothing but 2 cos square alpha minus 1, right? So there we are. And then I do not alter the denominator. I know that I can further simplify this above expression, right? How can I do that? I see that my 1 and 1 gets cancelled, right? I'm just highlighting this because I have a minus 1 highlighted in yellow and then I have a plus 1, right? These two get cancelled out and then I can rewrite my expression and I have a much simpler expression now. Now this becomes a lot simpler for us, right? I know that my cos square x minus cos square alpha is of the form a square minus b square, which means I can rewrite this as a minus b into a plus b. And what is my a minus b into a plus b? My a minus b into a plus b is nothing but my cos x minus cos alpha into cos x plus cos alpha. And now I know that I can cancel out my cos x minus cos alpha, right? I'm referring to the expression here in the denominator. Let me highlight it in yellow with what I have in the numerator, right? I'm again highlighting it in yellow. So there we are. This becomes a lot more simpler. So my dy by dx, we have simplified it to 2 times cos x plus cos alpha, right? Now I know that my y, which I wrote it before we started simplifying, can be rewritten as integral of 2 times cos x plus cos alpha dx, right? And this is not too difficult for us. I'm going to apply the sum rule of integration. So what happens to this? It becomes 2 times integral of cos x dx. I pull out the 2 And then I again have 2 times cos alpha. My alpha is a constant, so I can pull it out of the integral. So I have 2 cos alpha integral of dx, right? So this is what I have. Now, this becomes a cakewalk for us from here on. So y equal to 2 times integral of cos x dx is nothing but 2 sine x, right? And I request you to take a look at the integral formulas, what I have written down in the description. And then I have 2 cos alpha integral of dx is nothing but 2x cos alpha. I have my arbitrary constant c, right? So the answer to the problem is 2 sine x plus 2x cos alpha plus c. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.